Welcome back. This is a video lesson for the group Denominators for Monday, April 27th, 2020. Hope you had a nice weekend. We're back at it. Another week of online instruction. This week we are moving away from parallel perpendicular lines and from scatter plots, and we are moving on to something called inequalities. If you remember back, we did these in the very beginning of the year, but now we're going to be solving some inequalities with variables. An inequality is an open sentence that contains one of the symbols greater than, less than, greater than or equal to, or less than or equal to in the number sentence. So there are two different properties of inequalities that I would like to introduce to you today. And we're going to be working on these properties, both the addition property and the subtraction property, today and tomorrow. And then on Thursday and Friday, we're going to do the property of multiplication and the property of division. So first, let's check out this property of addition. It says if x is less than y, right up here, then x plus z is less than y plus z. Now, all this is saying is that if this x less than y statement is true, if we're adding the same value onto either side of our inequality, then this statement is still going to be true. Oops, sorry, I underlined my different values here. So if I add a z to each side, it's going to keep the inequality the same. It's still x is less than y. Okay, we're adding the same value to either side, but our balance or our scale is still tipped in one direction. Now, this has real life implications as well. I think it's important that we stop and talk about, well, why would I need to know this in my everyday life? Well, here's an example. Tom has $3 and Bill has $6. They both earned $5 for mowing the lawn. Tom still has less money than Bill, right? Because they started off where Tom has 3 and Bill has 6. You're adding 5 to each, so you still have 11 is less than, 8 is less than 11. You're adding the same value to each side of your inequality. Therefore, the inequality is still tipped in one direction. Now, the subtraction property of inequalities is the same. Okay, so for example, down here, I have x is less than y. Okay, if I take x minus z here and y minus z, if I'm taking away the same amount, well then x is less than y is still true. Okay, this statement or inequality is still true. Okay, my face here is blocking this, but you can see Mark has $14 and Dan has 16. Okay, they make the same amount of money. They spend the same amount of money at the mall. Mark still has less money than Dan. Okay, so these are the properties of addition and subtraction of inequalities. Now, we can apply these to a graphing. Okay, so here is a snapshot from our textbook, example number 2. We're going to be writing inequalities from graphs today. Okay, now it says write an inequality represented by the graph. Okay, now a couple of things that I want to go on over before we start. If you notice that here, this point on this number line has an open circle. Okay, if you see an open circle with a line in this direction, it means greater than. Okay, but when you have an open circle like this, it means it's not equal to the number graphed. Okay, if you see a closed circle, a circle that's colored in, okay, like, wow, that was really a nice job, with a line like this, what that means is that it is less than and equal. It includes that point, okay? So for example, here, this point 4, well, is closed. So that means that would be equal to that number. When it's opened like that, it means it's not equal. So it says write an inequality represented by this graph. So I'm looking at this point. This point is negative 6.5. This open circle means that negative 6.5 is not a solution to the inequality. Because the arrow points to the right here, see the arrow pointing to the right here? What that means is that all numbers greater than negative 6.5 are solutions. So the way that we would write an inequality for here is I would have x, and because everything greater than x, the direction of the arrow matters a lot, x is greater than negative 6.5. So I just graph this inequality. Now, not too hard, but you need to know what this circle means. And you need to know what the direction means greater than. Now over here, for B, I have a closed circle, and now I'm pointing to the left. So what does this mean? Okay, first, the close signal means that it's equal to the number that's graphed. Okay, so again, I'm going to have x. Okay, and since it's pointing to the left, that means that all numbers less than 4 are solutions. But not only that, but because the point is closed, we're going to say not only less than, but it also includes or could equal 4. So on this side, it's saying x is greater than negative 6.5, any number greater than. On this side, for letter B, x is less than, or it could also be equal to 4. Now, this is a very introductory lesson of 1, what an inequality is, 2, the property of addition and subtraction for inequalities, and then an example of how to graph some inequalities. Now, for your practice today, you are going to get a point, and you're going to have to graph it, and you're going to get a graph, and you're going to have to write it. So it's going to go both ways. Today, I only showed you the graph and having to write it, but there might be some where you're going to get this x is less than or equal to 4, and you're going to have to put it on the graph. I know that you can do it, but if you have any questions, please reach out to me during office hours, or you can shoot me an email. Let me know. I'm here to help, guys. So work hard, ask questions, and I'll see you tomorrow.